Hello. In this set of videos, we're going to go through and explore class hierarchies in further detail and specifically look at how to take a superclass and make it into an abstract class and talk about some of the benefits of that. One of the things I want to recommend as you go through these videos is don't get caught up in how certain methods are executed. There's simply some code in there for the sake of having some code for this example. In other words, there's one method in the sheep class we'll talk about where we calculate how much value a sheep's fleece is worth. Don't get caught up in that calculation. That's not important for the purpose of this exercise. What we want to understand is why we structured this program the way we did, placing methods in certain places. So before I even start my program, I have to go through my design specifications. So here are my design specifications. 1. In my program there are two types of animals, sheep and lions. 2. Lions and sheep have common fields, that is name, age, and strength. 3. Lions have no unique fields. That means that lions have nothing unique about them. They only have a name field, an age field, and a strength field. On the other hand, sheep have unique fields in terms of their herd and wool. That is, there's a size of their herd, called herd size, wool quality, wool ready, and wool length, each representing different aspects of the sheep. Sheep and lions protect themselves differently. There's no common behaviors between the two of them. So there's some method which simulates the sheep protecting itself or the lion protecting itself, and the key thing in my design specifications is that there's no common code. Sheep and lions have common eat elements. That is, when they eat, their strength increases by 1. However, with lions, since they're hunting to eat, they're not always successful. So there's some unique code in the lion's case. A sheep, on the other hand, always eats grass, so it's always successful. Sheep and lions have common sleep elements, meaning that they sleep in the same way, and when they do, their strength increases by 1. Similarly to the eat methods, there is some unique code, specifically for the sheep, because sheep can't sleep if there's predators around. However, lions can sleep whenever they want, since no one hunts them, at least in context to this program. Finally, sheep have a unique method which simulates the shearing process, that is, taking the wool from them. And what that does is returns a double representing the value of the wool, based on some random formula I came up with. Again, don't get caught up in whether or not this formula is accurate. The key thing with this is to kind of look at how we've constructed this class hierarchy. So now we have a little visual depiction here. And so we see we have a superclass called animal, and then two subclasses, one called lion and one called sheep. So we're going to create a class called lion, which extends animal, and we're going to create a class called sheep, which extends animal. Since both sheep and lion have a name, an age, and a strength, those fields would go in the animal class. Since both the sheep and the lion sleep, eat, and protect themselves, we're going to put those methods in the superclass. The superclass, of course, is going to have your accessor methods and your mutator methods. And then the superclass is going to have a two-string class, which is going to somehow represent the various fields in a specified manner. Now, like we said, the lion eats differently than the sheep, so we're going to have a unique eat method in here. So what you'll notice here is that there's an eat method in the animal class, but we've overridden that method with another eat method in the lion class. Take note that there is a second eat method called with a Boolean parameter. That one was written specifically in the program. We'll see why that is there. But it's important that you connect this eat method here with this eat method here. Okay? Again, the lion is going to protect itself, so it has a protect method, and there's no accessor or mutator methods in the lion class, as well as there's no toString method in the lion class because the lion has no unique fields to output. We come over to the sheep class. the sheep is going to have a static field called herd size, because whenever I add a sheep object, I want to increase the number of sheep in my herd, and that's going to be the same for everyone. We'll assume one herd in our program for our discussion. It has an integer which represents the wool quality, and actually I've changed that in my program to a double. Interestingly, I did quite a bit of reading about wool quality for this program. And that's one of the neat things about computer science. Whenever you're writing a program, you're going to have to do some background reading to really see if you understand the topic that you're implementing a program about. Wool ready represents whether or not the sheep is ready to be sheared. And wool length talks about the length of the wool. So again, there's a couple methods in here. There's shear sheep, which is simulating the process of the sheep being sheared. There's a protect method, and again, we need a special protect method because the sheep has unique protect behaviors. And there's a sleep method because the sheep has some unique sleep behaviors that we have to account for. The sheep will have its own set of accessor and mutator methods, which I haven't listed, and the sheep has a unique toString method because it has unique fields we have to output. So a really important thing to pull out from this diagram here, my design specifications, is that you'll notice eat is listed in the animal class and the lion class, but not in the sheep class. And the reason that is because since the lion and the sheep eat in a common manner, that code is going to be put up in the animal superclass. Meanwhile, the unique chunk of code is going to for the lion will be put down below. There's no unique code for the sheep, so therefore it doesn't need an eat method. Likewise, we have a sleep in both the animal class and the sheep class, and that's because the common elements of how sheep and lion sleep will go in the animal class, and the unique code for the sleeping processes of a sheep will go in the sheep class. The last thing to take note of is that there's a protect method in each of the classes. Now, in our design specifications, we said that we have no common code for the protect method, and so we might be able to pull that out of the animal class altogether because there's no common code. But at this point, we have to leave it in, and you'll see in the next video why that is. I hope that helped.